My name is Ethan Seprin. This is my final project for Engineering 1035 at Salt Lake Community College for the fall 2023 semester, and this is Operation Rover. A little background before we get into Operation Rover. Throughout Engineering 1035, we use software called MATLAB, and MATLAB is an awesome computer program that allows you to solve equations, problems, whatever you need. It has tons of applications. Inside this, we use Simulink, though, to create programs that we can implement into robots and all of these different hardware boards and such. So, there's countless ways to integrate Simulink into the real world, but the awesome part about it is that Simulink uses visual blocks to create these programs. And so it is very easy to see the progression of order throughout a whole program because you follow it with lines. If this isn't equal to this, then this doesn't happen, then this does happen, and it's very universal. But there's lots of things here, and the commonly used blocks like constants, gains, which is a multiplier, a product, which is multiplication, or in the specific Lego Mindstorms EV3 category, we have, the color sensor, motors, the speaker, all of which we'll be using later on. Well, so to continue the background, here we have the constant block here. We have the color sensor, which is called a ground sensor because it, senses things on the ground. Another constant block, product, two motors, but you can see is that if the color value is greater than or equal to the color threshold, a true or false, either a 1 or a 0 will go through. 1 if true. If it is true, the product of the set speed times that will then go to each of the motors. If it's false, it will be 0 times 50 equals 0. It will stop. Project goals: create a system that will stop on a randomly placed black square inside an 8 by 8 foot area, or as big of an area as I can make in my apartment. Be fully autonomous, meaning whenever it starts, or the program starts, I can't interfere with the robot anymore. Obviously, then, the troubling part of that is that the robot has to avoid obstacles in its path. And finally, the robot should be able to complete it in a timely manner. We don't want this robot taking all day to find a black square inside an 8 by 8 foot area. It shouldn't take that long, and there's lots of ways to adjust that. So the robot configuration, I didn't make any changes to the configuration. As you can see here, this is the touch sensor, which we don't really use, and the gyroscopic sensor, which we don't use in this, but they are useful in other circumstances. I just didn't find any simple or effective use for them here. Let's see, the light sensor is a big part of this project because that's what determines whether it stops or not. And we also have the ultrasonic sensor, which detects how far objects are away from it. And we use reflected light intensity to determine if the robot stops or not, or what data is being fed to the robot. And the process of creating this is we needed to use persistent variables, which creates different states for the robot depending on the conditions that the robot meets or the surroundings meet, which include the ultrasonic sensor or the light. So to do this, I had to work backwards. First, I had to create a model that stopped on a black square. And so I designed the robot initially to go in a straight line and stop on the black square because I needed to know that the robot will stop. Otherwise, it's hard to work with states because otherwise you don't really know if the robot's actually doing what it's supposed to be doing. You have to make sure it works before you can expand on it and really grow. And then after that, I added in different states where the ultrasonic sensor was detecting obstacles, and if an obstacle is within a certain range, the robot would go to a different state, turn around, spin. The motors or the wheels are moving at different speeds that it would turn, and there would be well, we'll get into it later, but the end all be all being if the light sensor is meeting a certain criteria, then the robot stops. And so here's a progression. Here we have a light sensor, what the threshold to make the robot stop. This just set speed. I also programmed it to make a noise whenever it found the black square as well, so that I knew that it completed the program. And then we have the two motors. And what you'll see here is that this whole left side is inputs, this whole right side is outputs. And you see the outputs there, and then we have the inputs there. And so we have, persistent variable. State is the persistent variable, initially set to 0. This can be a little confusing, but this is the programming to switch the state. So the initial state is case 0, right wheel and left wheel are set to the same speed, speaker is 0, but this if statement is what changes everything, or changes the state. If the color value is less than or equal to the color stop value, then the state changes to state 1. And in case 1, right wheels, the wheels stop moving and the speaker starts blaring out as very loud. Otherwise, if it gets lost or in something random, it's just built to spin around. And here is our final thing, color sensor, color stop. You can see it's very similar to what the last thing, inputs on this side, outputs over here. That's not any different. Set speed's a little quicker to get everything done faster. We have the ultrasonic sensor and the distance threshold set in there as well. And so this is very, very similar to what is done before, but added a few other things. And other blocks that are pre-made, because this is a self-made function that I did myself. These values are naturally doubled, so you have to double them when you do it yourself. And so natural first state is that robot is going in a straight line, and if the color value for all of these is less than the color stop, the state will automatically go to number 2. Otherwise, if the ultrasonic sensor detects something within the distance threshold, the state will then move to state 1, and while in state 1, it will just be going backwards, but we're also adding spin, because at the end here we have the right wheel output and left wheel output equal to right wheel plus spin, left wheel minus spin, so that the robot will turn. Again, we have the if color value. If it finds it while turning, it will stop. And then I believe everything below here is the new stuff. This is redundant. And then case 2 is if the robot stops, spin 0, it stops moving, but all it is that the speaker lets us know that it found the black square. And then the results, it was a success. I mean, the robot completed the final objective perfectly fine. It was a little, maybe it's a little slow, but I think 27 seconds is very reasonable for an 8x8 foot area. Issues, ultrasonic sensor didn't always like to pick up the cardboard. I added some paper along the walls to give some texture. The ultrasonic sensor doesn't always extend the whole width of the robot, so that can be a little difficult, so the wheels might run into stuff. And the light sensor likes to pick up dark spots on my apartment floor, so I just covered the whole floor in white paper for consistency, and here's it in action. So there you have it. Going forward, I think it would be a lot faster if the robot would sweep, or if I could make the robot sweep while going in a semi-straight line. It would just cover way more surface area and is less likely to miss the target. I could use the encoder block, the clock or the gyroscope as persistent variables. The individual wheels turn X degrees before going to the next state. The robot runs a certain state for X amount of seconds before continuing to the next state. Or, the robot turns X degrees before going to the next state. Instead of having spin doing that, I honestly just simply ran out of time to explore these more complicated options because I'm leaving the country. So I kind of ran out of time with that. And I also honestly, very simple program. I know it's very simple, but it executed the objective very well. And I'm not sure if any more complicated programs would guarantee better results, so I didn't want to mess with something that already worked. And it was easy to adjust the inputs, the speed especially, spin, you'd have to go inside the function, but why change something if it works very well?